All right, so 7, 2. Let's do... Oh, this was having trouble before too. Oh, yeah. Oh, there we go. Okay. Let's do it. 7, 2. Division properties of exponents. Okay. So yesterday, when we multiplied with exponents, we added. What do you think we will do when we divide? Subtract. So, first property. Quotient of powers. If you have an expression, a to the m over a to the n, you subtract the exponents. A to the m minus n. Okay. Power of a quotient is like product of a power of a product, like yesterday. But here, a over b raised to the m is just that. A raised to the m, b raised to the m. Okay? So you're like distributing the exponent. Example 1. Here's our first one. 16 x to the 8th y to the 6th, 2 x to the 5th, y to the 4th. All right. So when you take a look at this, let's start with the variables first. So what we do with x to the 8th divided by x to the 5th? What will be the new exponent?
X to the 3rd, y to the 7th.
X to the 3rd. And then y to the 6th over y to the 4th is y squared. Now, here's the mistake people will make when they work with the numbers. Because what they're thinking is, they think, oh, division, exponents, I subtract. So people will subtract the numbers in the front. They'll do 16 minus 2, and they will write 14. Do not change the problem. Just write 8. Okay? In parentheses, 3x to the 3rd y squared over 2x y raised to the 3rd. So there are a couple, when you see problems like this, there are a couple different ways that we can go about solving them. we can either work with the stuff on the inside first, or we can deal with the exponent on the outside. Let's distribute first. So that's going to be 3 to the third times x cubed to the third times y squared to the third over 2 to the third x cubed y cubed. Okay. So we distribute the exponent to each piece. Now we simplify. So that's 27 x to the 9th y to the 6th over 8 x to the 3rd y cubed. Now, can we reduce 3/2 into something simpler?
1 and 1/2.
Not a mixed number. That's as simple as it can go, right? Like 3/2. That's it. Nothing that goes into 3 also goes into 2. Because we have cubed that, 27 over 8 is the simplest it will go. Okay? Because of that. So my answer is 27 over 8 x to the 6th y to the 3rd. You could also write this as 27 x to the 6th y to the 3rd over 8. Okay? Those are the same answers. Okay. Now, the next thing that we're going to talk about is special, is other exponents. Work on your homework later. Yeah. Is that your homework?
Yeah.
Yeah, work on it later.
Well, do I need to turn it in today?
Yes, you do. But you have work time after this. Well, you have to turn it in Monday then. Put it away.
What?
Put it away. Now we need to talk about exponents of 0. When we have an exponent of 0, this is coming from an expression that would look something like this. If the exponent is 0, then that means we are subtracting the same number. Well, if we kind of flush this out, a squared over a squared is a times a times a. Well, cancel out, cancel out. What does this equal?
0.
No,
1.
it equals 1 because everything cancels out. So when you have exponents of 0, it just equals 1. Now let's talk about negative exponents. With negative exponents, we will never want negative exponents in our answers. If we think about the expression b to the 3rd over b to the 5th, if we expanded this, it'd be b times b times b over b times b times b times b times b. Okay? These b times b times b on top cancel with b times b times b on the bottom. So I'm left with 1 over b times b. This is because b to the 3rd minus 5 is b to the negative 2, which is 1 over b squared. Okay, so we don't want negative exponents. Okay, so our negative exponent property tells us this. A raised to the negative n is 1 over a to the n. Likewise, 1 over a to the negative n is a to the n. Okay? So with negative exponents, what's going to happen is if it's negative on top, it becomes positive on the bottom. If it's negative on the bottom, it becomes positive up top. Okay, so it kind of flip-flops. And we are talking about the reciprocal here as well. Okay. So here is our last example. Write each expression with no negative exponents. Here's the first one. X to the negative 4. Y to the 9th over z to the negative 6. So this is a pretty straightforward one. When you look at something like this, it is as simple as taking that x to the negative 4th, making it positive in the denominator, taking that x to the negative 6th, and making it positive in the numerator. So my answer is y to the 9th, z to the 6th, over x to the 4th. Okay? They just flip around. $75 p to the 3rd, m to the negative 5, r to the 0, divided by 15 p to the 5th, m to the negative 4, r to the negative 8. What I want you to know is that the properties that we're seeing today, and even the properties from yesterday, they work with negative numbers. Okay? So, 15 goes into 75 6 times. But then I have p to the 3rd minus 5, because I'm doing 3 minus 5. M raised to the negative 5 minus negative 4. R raised to the 0 minus negative 8. Okay. So I'm using that very first property. This gives me 6p to the negative 2, m to the negative 1, r to the 8th. When I do that simplifying. And I could have gone from this to this as well, from here to here. I could do that as well. Okay. Answer, 6r to the 8th. And then what's in my denominator? Go ahead.
P to the 2nd and m.
That's it. Right. So all the properties from yesterday work with 0 and negative. We're not going to see exponents. All of our exponents will be like integers. When we come back next week, we will talk about exponents that are fractions, which all of these properties work with as well. Your homework is 20 through 30 even. I'm coming 33 minus 41. Hello. Yes, Allison. All right. I hope you have a good Thanksgiving.
What page?
It is 403. Alrighty. So, you have a half an hour. Okay? Do you think that you could finish this before you leave? Alright.